This is the eSolution for problem 6 in Segel's biochemical calculations. It's in page 319, problem 6. Problem number 6, and the page is 319. And this problem states that an enzyme with a Km of 1.2 10 to the power of negative 4, so this enzyme has a Km of 1.2 10 to minus 4 molar, was assayed at the initial substrate concentration of 0.02 molar. So the substrate concentration was 0.02 molar. First thing that comes to mind is the concentration of the substrate is very high. So by 30 seconds, 2.7 micromolars per liter of the product has been produced. So 30 seconds after this substrate becomes product, we have now a concentration of this product of 2.7 micromolar. One important issue here is that we are working at a very high concentration. The concentration of the substrate is way higher than the Km, right? So the concentration of the substrate way higher than Km. So therefore, we are here in a zero order reaction. Do you remember this situation where we have this graphic like that? This is the velocity, this is the substrate concentration, and things become like that. So if the substrate concentration is much larger than the Km, the substrate concentration is much larger than the Km, then we are in a zero order reaction. So this is completely independent of the concentration of the substrate, right? So in that particular case, the velocity of the reaction is going to be basically how much product was formed in a certain interval of time. So we have here the formation of the product. It was 2.7 micromolar, and this happens within 30 seconds. So divided by 30 seconds, so to give us the velocity of this reaction. So it's going to be 0.09 micromolar per second. That's the velocity of the reaction, because the zero order is independent of the concentration of the substrate. It's already plateaued there, right? Now the question asks is the A, how much product will be present at 1 minute? At 1 minute, time now is 1 minute. Then all we have to do is to calculate this for the same way. Since we are working with seconds, it might be better to use 6 seconds instead of 1 minute. And we have then that the velocity of the reaction was delta P over delta T. So in that case, delta P equal V delta T, right? So we now want to know the product, the amount of product that was generated. We know now the velocity of the reaction is 0.09, and in this case in here we have 60 seconds, right? 60 seconds, 55, 5.4. 5.4. Don't need that calculator for this one. 5.4 micromolar. That would be the answer for part A of this problem. Okay, let me scroll down a little bit here so that we have more space to do the part B. In part B is asking what is the product after 95 seconds. Same exercise, except that now we are going to have that with 95 seconds. So that will be delta P equals 0.09 times 95. Okay, 0.09 times 95. So 8.55 micromolar. Easy, right? C, we have the same type of things with 3 minutes. 3 minutes. Might be better to have that thing in 108 seconds, so to avoid any problem, delta P is going to be 009 times 108. 108. That's 16.2 micromolar. All right. So D is asking for 5.3 minutes. 5.3 minutes. D equal 5.3 minutes. We first of all multiply this thing by 6 to get in seconds, right? 5.3 times 6 is going to be 318 seconds. Then we have now the same formula, 009 times 318 times 318. 318 is already here, times 009, so it's going to be 28.6 micromolar. And the problem continues, and they ask in letter E, what percent of the original substrate will be utilized by the times indicated? Now it's asking about the percent of the original substrate would be utilized. We look at the product, right? We look at the formation of the product. Now we're going to be looking in letter E at the formation of the how much was used, right? So we had initially in letter E, we have a 5.4 10 to minus 6, right? 5.4 micromolar we have initially. And how much of this, out of the starting material, that was 2, 10 to the power of negative 2. And if we multiply this thing by 100, then we get exactly what Segel is asking. What percent of the original substrate was utilized at the time? The first time is the time at 1 minute, right? So let's do this calculation here. Let's work these numbers. So this is going to be 2.7, right? It's going to be 2.7 and 10 to the power negative 4. But there's the 100 here, so the negative 2 in percent, right? The next one that's come from letter B, in letter B we had 8.55 10 to minus 6, remember? 8.55 micromolar out of 2 10 to the power of negative 2, and times 100 to make in percent, if you so desire. And the same thing in here, that will be a 2 divided by 4.27 10 to minus 2 percent, right? Next one is it was 16. When we have 3 minutes, we have 16.2 micromolar, 10 to minus 6 divided by 2.2, 10 to minus 2 times 100. This would give a 8.1 10 to the power of negative 2%, right? And last one, the last one gave us 28.6 micromolar. So let's do that exactly here. 28.6 10 to minus 6 divided by 2.2 10 to the power of negative 2 times 100. This would give us, let's make sure that we get this thing right here, divided by 2. That's 14.3 10 to minus 2%. That's the solution for problem 6 from Segel's biochemical calculations.